Hello, I am Krish Panchal and my teammates are Yash Kulkarni and Aryan Parekh. Our blockchain IA2 topic is report and case studies on blockchain in healthcare. Let us start this topic with the introduction. The healthcare industry faces numerous changes related to the management of patient data. Electronic medical records are critical for delivering efficient and high quality care, but issues such as incomplete records, delayed communications, and data fragmentation hinder the seamless exchange of information among healthcare providers. This paper explores the potential of blockchain technology to address these challenges and enhance contracts using Ethereum's blockchain network for secure and efficient EMR, which is electronic medical records storage, while reducing storage costs through off-chain solutions. Now, let us see the case studies of blockchain in healthcare. The first case study is MedRack, which is a patient-centric medical records management. First, we'll see the background, followed by the challenge, and followed by the solution. So let us check the background first. Medrec is a blockchain-based solution that prioritizes patient-centric medical records management. It addresses the challenge of patients having fragmented health records across multiple providers, making it difficult to access and share their complete medical histories. Now let us see the challenge behind this case study. Metric. The challenge was to create a system that allows patients to have a greater control over their health data while ensuring the privacy and authenticity of their records. Additionally, it aimed to address the issue of interoperability among different healthcare providers. Now, let us say the solution. The solution employs a permissioned blockchain system that manages authentication and data sharing. Patients are given the authority to control access to their medical records through smart contracts. When a patient visits a healthcare provider, they grant temporary access to their records. This not only enhances data security but also ensures that the patient's complete medical history is accessible to the healthcare provider, leading to more informed and efficient care.
I am Aryan Parekh. So let's look at the next case study, which is Blocky. Blocky stands for Blockchain for Healthcare Information Exchange. So let's look at the background of this case study. This talks about as Blocky was designed to revolutionize the healthcare information exchange by addressing various issues such as privacy, authenticity, throughput, latency, and fairness, which are really important based on the security and performance perspective. So what it used to do is that it used to recognize the challenges in a very secure and efficient manner of sharing healthcare information. The first challenge that was posed to this approach was that to create a system that will allow healthcare information to be exchanged very securely and efficiently while still maintaining privacy and authenticity. So what it aimed was to overcome the issues uh, related to traditional healthcare data exchange systems that are often very slow and vulnerable to many data breaches. So the solution that was proposed to this challenge was that Blocky would leverage the blockchain technology to create a trust-based ledger system for healthcare data exchange. So it also used smart contracts and cryptographic techniques to guarantee privacy and authenticity of data. So this ensured that data is not only secure but also shared fairly and efficiently among the relevant parties. So finally, it has the potential to transform the way healthcare information is exchanged and accessed. So the next case study was based on blockchain for diabetes healthcare data and access management. So let's look at the background of this case study. This proposed that the concept enters on using blockchain to empower diabetes patients to effectively manage their health data and promote cross-institutional sharing on a secure platform. So the challenge that was posed to this idea was that to create a system that will allow all the diabetic patients to have control over their data while ensuring security and accessibility of this information to only relevant healthcare providers. Managing diabetes effectively often involves collaboration among multiple healthcare providers, and fragmented data can hinder this process. So, a solution which was proposed to this challenge was that a blockchain based platform should be employed, enabling the diabetic patients to manage their data and grant access accordingly to only relevant healthcare providers as and when needed. Smart contracts govern data sharing permissions, and the blockchain ensures the integrity and the security of the data stays intact. So, this approach facilitates a better data management and patient care for those living with diabetes.
Hello, this is Yash Kulkarni and I'll be taking over. So let's talk about the third case study. Blockchain for diabetes, healthcare data and access management. Okay, so firstly let's talk about the background. This concept centers on using blockchain to empower diabetes patients to effectively manage their health data and promote cross-institutional sharing on a secure platform. The challenge here is that was to create a system that allows diabetes patients to have control over the data while ensuring the security and accessibility of this information. It is to be accessible to relevant healthcare providers as well. Managing diabetes effectively often involves collaboration among multiple healthcare providers, and fragmented data can hinder this process. Okay, so what about the solution? A blockchain based platform is employed, enabling diabetes patients to manage their data and grant access to healthcare providers as needed. Smart contracts govern the data sharing permissions, and blockchain ensures the integrity and security of the patient's information. This approach facilitates better data management and patient care for those living with diabetes. Moving on to the fourth one, IBM Rapid Supplier Connect blockchain for supplier identification. Okay, so IBM Rapid Supplier Connect was developed to support supplier identification in the healthcare and government sectors, particularly during COVID-19 pandemic when there was an urgent need to verify and engage suppliers rapidly. The challenge here was to quickly identify and verify suppliers to meet the critical demands of the pandemic by ensuring the security and reliability of the supplier data. Reliable suppliers identification was crucial for procuring essential medical supplies during the crisis. The solution was a system leveraged blockchain technology. The system that leveraged blockchain technology to efficiently verify and supplier identities and ensuring integrity of supplier information. This improved accuracy and reliability of supplier data, which was crucial in the rapid procurement of essential medical supplies during the pandemic. Blockchain's tamper-proof nature and transparency enhance the reliability of the supplier's identification. Okay, so the way the system is built is, the idea is that the files, that is the data of the patients, is stored in an interplanetary file system. The hash of that file of the data is then stored using a Ethereum smart contract. It is referenced within a Ethereum smart contract, and the hash of the file is stored within the blockchain. So, focus of the research, the primary focus is the data. The paper primary focuses on data storage for electronic media, medical records, of using an off-chain approach. Here we employ a interplanetary file system, and these data is referenced within smart contracts. This approach minimizes storage cost while ensuring data integrity. So how do we retrieve the storage data? Smart contracts are employed to manage ownership, metadata, permissions, and data integrity. Patients and healthcare providers have access to the medical data based on their private and permissions defined within the blockchain. A DNS-like implementation maps the existing forms of identification to Ethereum addresses for seamless access control. So here we see the client's data is stored in this IPFS, that is interplanetary file system data store. The access can only be provided through the blockchain using smart contracts.
Let's look at some of the challenges of this of the blockchain technology adoption to the healthcare sector. is that the immutability feature of blockchain poses a lot of challenge regarding the right to be forgotten, since data cannot be easily erased from the blockchain and can uh, arise privacy concerns among the patients that there if the encryption fails, then the adequate protection might not be provided to the sensitive patient's data. So to tackle this issue, off-chain storage and permission blockchains are proposed. So finally, concluding our report, we suggest that this solution of proposing an electronic mail record using blockchain technology, particularly Ethereum, with a focus on off-chain storage, can be very beneficial and be proved as a revolutionized idea in the healthcare segment of data protection and securely accessing patients' data by relevant healthcare organizations. So this can also help us solve numerous data problems and healthcare challenges. But there are still some hurdles regarding this to adopt this widespread. So this paper has potentially helped us to line out some advantages, but also has made us aware of the challenges that exist to adopt this. However, like if to acknowledge the need of this data privacy issue and access control, there are still amendments being made to blockchain in the security perspective and encryption perspective. Also, Deloitte has also conducted a survey regarding the broader ecosystem of blockchain to understand how this can be beneficial in the healthcare aspect. So, blockchain in the healthcare sector might be a huge revolution in the future to look out for. Thank you.